Hi, welcome to this presentation I made to Geotecnia Brasil. I was invited by Tiago to make this presentation, and I was very thankful for this invitation, the opportunity to share with you our experience, what we are doing here in Norway. I'm Jeovan de Freitas. I'm structural engineer, associate professor at Østfold University College in Norway. We are in Fredrikstad, south of Norway. Well, I will make this presentation about large infrastructures projects in Norway. Nowadays is the main scope of developing in Norway is to improve our almost all infrastructures in Norway. Well, just give a little introduction what we are talking about. When we think in developing countries or like Norway, we think all infrastructures are well done, make or very big, like those roads, big roads with big bridges crossing fjords or mountains or big double lines. Well, unfortunately, this is not the case of Norway, because in fact Norway have more or less this like roads, very very narrow, crossing the mountains or crossing lakes, fjords, or even crossing mountains or snow during the winter. So that brings us a lot of problems in the traffic in Norway. For instance, a good example is this Trollstigen Vine, is the famous mountain road in north of Norway. Is very famous because of his deep or sinuous curves to cross the mountain. The problem is that this road is only open in the summertime. During the winter is practically closed. So this road is very often open in midst of May. So that means from almost October to May is not possible to cross this road. So if you see here, this is the operation that they did this year to open the mountain. There was a lot of snow last winter, and they have to use big machines. So they take almost 5,000 tons of snow, and they dig almost 10 meters deep. So you can see that it's a very complicated process. So that's a problem for road transportation in Norway. So that means there is some roads in the mountains that are closed a long times of period. So the option is the nature option is big tunnels to cross in the mountains. And this is a good example is the Larendal Tunnel. Is the almost 25 kilometers long road tunnel connecting Larendal or Aurland in Vestland County in Norway. It's almost 200 kilometers from north of Bergen. Is the main road for X16 connecting the north of Norway with the coast of Norway. And this very particular interest of this road is that in the middle of this tunnel you have a roundabout. So as you can see here in the picture, you can have a roundabout in the middle of a tunnel. That is something that most of the people don't expect to see when you are in a tunnel. We have also the very famous Atlantic Road, also in the region Atlantic Vine. That is very famous because they use in the natural islands in the north of the North Sea to build the road. So the trace of the road was defined not by the engineers, but the nature and how they could connect these small islands to build the road. It's a very famous road in the Norway, and you can see by the pictures, it's a very nice road to crossing. Together with that, recently in southern Norway, close to Oslo, they started developing highways. So in this process, a lot of bridges has been made, and bridges and tunnels. And the interest project I want to share is the Ferris Bridge, or how we call in Norway, Ferris Brua. Is a crossing the Ferris Lake, just north of Larvik, south Norway. And this bridge is part of the expansion of the 18 motorway from antiquated single carway to a big highway. So this bridge is a composite bridge because you have concrete sections with steel sections. Is 507 meters, is 28 meters higher, and however the maximum span 28 meters. And this bridge is interesting to see this foundation process. So the bridge's biggest foundation is that in the tower, of course. The foundation is made of 12 pillars, steel tubs measuring approximately 2 meters in the diameter. You can see when you compare someone close to these pillars. And this is really through the mooring masses down to bedrock. And then filler with armor and concrete. The deep down to bedrock is around 18 meters. Top of these pillars, concrete plate was made 4 meters thick and covering with almost 24 acres of concrete. So this is a view, the concrete section that was made. And the towers, the concrete towers, some was built to support the cables, and the sections of the concrete bridge that was made. As I mentioned, the main span of the bridge was steel sections, so they are assembled in pieces, pieces. Some come together to connect the bridge, the steel section, to concrete sections. It's just a know. But what's very interesting on this project, in fact, is not the bridge itself, is how the project was connected. Because the bridge itself is the end two tunnel sections. The Martin Olsen tunnel and the Gupdal tunnel. So it's two tunnels, some connect by a bridge. And here you can see the profile of this tunnel and how deep they are made. Here we can see short videos where you can see the experience, what is the experience to drive this tunnel. And I have to admit, it's a very good experience, especially when you go in. I will talk about those mountains rock here after, because it's kind of interesting to discuss what happened. So you can see this tunnel, the concrete section. The tunnel is based on concrete sections, plates. So they are using to protect the structure, the concrete, the tunnel structure. So it's placed by sections. The tunnel excavation was not by blasting, was by drill excavation. Due to the characteristics of the rock, it was not appropriate to use blasting process. So they have to drill and open the rocks. Also, the problem, the blasting was above the city was above the tunnel, so it was not appropriate to use a blasting process. So you can see there is well illuminated. Also, all axes, emergence axes are very well illuminated. It's almost one exit for each 500 meters. So it's a very safe tunnel in case of the accidents, so you can use. And it's very spectacular when you finish the tunnel, comes the bridge. It's very nice to see this effect, how you come out from a tunnel and take out a bridge. So it's a nice road trip if you think about it, and very safe. But not everything goes as planned very often. In December of 2019 was an accident in the access to the main tunnel. The sections of the rocks fall apart, so collapsing, closing the main entrance to the tunnel. This collapse was not inside the tunnel, it was before the tunnel, was the rock excavation. And you can see here what's the effect of this. Well, this is still under investigation, but the main cause was some experts have almost defined, but the main cause was the problem with the anchorage system to protect the rock. Was not deep enough, because the characteristic of the rock you can see here is very fragile and very broken, and the anchorage system was not good enough. And to complement that, they have detected this anchorage system also have the effect of the water go inner the anchorage cables, and during the winter this expand and giving more fracture in the rock. And especially that was a very fractured rock, that was not a good solution. So they have to reopen, before they reopen the road, they have to make a lot excavation, make a new reinforcement procedure to these rocks. Well, not everything is failed. We have this another project that was concluded almost 5 years ago. Is the Hardegrand or Hardegrand Bridge. It's a suspension bridge across Østfold in Vestland country. It's close to Bergen also. The interest of this bridge, this suspension bridge, is that is the longest so far suspension bridge in Norway, and have a total length of 1,308 meters, is with 20 meters, its height 200 meters, and the long span is 310 meters. And the clearance is 550 meters. This is an overview of the sections that was making. All steel sections of the bridge was transported by boats. They are built in China and sent to Norway. Was steel sections. And this is just to have an overview of the dimension of this bridge in comparison of the other bridges in Norway. Another kind. And here we can see a little more details on the section of the steel decks, how they are designed, the couplings, the cables system, and the anchorage system of the cables, and of course how the cables were designed and placed. And here is a short presentation of the process of construction. Was first the short towers was begin, and then the cables was placed in the towers, and after the deck sections of the bridge was put in place. But maybe the most interesting process that happened now in Norway is the ferry-free A39. It's maybe the biggest infrastructure project in the world at the moment. It's a very interesting process because have a lot of engineering challenges. So the ferry-free, as we call in Norway, ferry-free E39, is the main project to stretch the existing E39 highway between the cities of Kristiansand and Trondheim in Norway. It's almost 1,100 kilometers long. The problem of this road is that as today there is a lot parts of the roads that you have to use ferry to cross the fjords, as shown here in red. And is almost 7 ferry crossings. So the main idea of this project is to replace some of these fjord crossings with other alternative routes like tunnels or bridges to reduce the time travel along the west coast of Norway. The project that have cost limit of 60 billion Norwegian crowns, approximately 1.7 billion euros. And construction is planned to complete in 26, but the last new planning is to complete in 2030, later on 2031, 25. Just to give a perspective what we are talking about, if we take a drive from Stavanger to Bergen, is just 210 kilometers. But due to the ferry crossing time, you can have almost 5 hours trip. That's very long. The other option is using the mountains and can be even longer in the time. It's not so long in distance, but in the time can be very long, 6 hours long. And we are talking about this in the good summer day. In a typical Norwegian winter time, we talk about almost 3 or 4 hours more. And here is some ferries that you have to cross. Okay, some people can say, okay, using the crossing ferries can be, it's not a problematic because you can have some relaxed time in drink a coffee, also using this time to see the views of the fjord. Of course, that is a good option, but not normal. You can have a very nice weather, so you can have some problems that sometimes, as in the view, that you have some storms crossing the fjords and can sometimes be very problematic. In recent years, there is a lot storms in Norway, and during the crossing ferries, we had a lot of accidents. This was during a crossing in the storm. A truck inside the ferry just rolled over and crushed some cars. This is another example. Was a concrete truck that roll over inside a fjord, and this was inside deck another ferry. Some have a problems during the storms. So, and this, although it's not very often, but can be very problematic in sometimes. So, we have to consider that the government have to consider what kind of bridge they can use in the process. Here is just a short review what kind of bridges we can use. But the problem was each bridge has its own limitation regarding the span. For example, a cantilever bridge is very limited. The maximum span some can hold as arch bridge or cable stayed bridge. The most appropriate to cross fjords sometimes is suspension bridge because give you more span length. Also, you can have more free span between the bridge and the water. So the government tried to understand the experience from another projects. For example, the Akashi Kaiko 91 bridge from that was almost 2,000 meters free span. That still have the record of the longest free span bridge. There was the project of Messina Bridge, was 3,300 free span meters free span that was in conception, but was not big yet and built yet. And there is another experience in the regions itself with a floating bridge process that's still state of the art, and there is not so far no submerged floating tunnel experience, although there is a lot of experience in from another type of submerged tunnels. For the point of view of the Norwegian experience, there is this Northlandsbrua bridge, was 1,240 meters floating bridge. So you instead have a normal column deep in the water, you have some these pontoons elements, so they are floating and fixed in the bottom of the fjord. So this was the most option that the government have considered to crossing the fjords. Of course, to have the experience technology from offshore industries. For example, Norwegian have a good experience with deep elements from the troll platform that is 303 meters deep, the biggest concrete element ever made. So they have also experience for floating platforms where the structure is floating but is anchored in the seabed by cables, and they have a lot of experience in the subsea pipeline system. So The main idea is to use this experience from offshore in these projects. So just to give a short overview that the options, for example, we have some fjords. Halsenfjorden is 2,000 meters crossing and 200 meters deep. It will be a project combine bridge, style bridge with tunnel. We have a Moldfjorden is 1,600 meters with a bridge combination with 13 kilometers of subsea rock. There is Storfjorden is approximately 3,000 to 3,040 kilometers crossing and 500 meters deep. Voldefjorden and Norway. So these are the projects that is current in development. So they have, most of them was designed with the flow combination of the suspension bridge and tunnels or floating system. This is an example, Moldfjord. So is a combination of tunnel with a suspension bridge. This project is under development and probably will start later on this year or beginning of next year. But this is not the most challenging fjords crossing that we have in this project. Maybe the most challenge are these three. The Sognefjorden, that is 3,700 meter crossing, and we have a deep of 1,300 meters. We have a Bjørnfjorden, that is almost 5 kilometers crossing, 500 meters deep, and possibly to bypass with 1,3 kilometers. And you have a Boknafjorden that was almost decided, is 25 kilometers of subsea rock tunnel based on 360 meters deep. So let's talk about the Sognefjorden, maybe the most challenge fjord to cross in this project. Is the options that was available was considering cable stay bridge, floating bridge, and submerged floating tunnel. The subsea rock tunnel was not considered on this case because it's not viable or it could be very expensive also. So this is just overview what we are talking about. We are talking about 3,700 meters length. We talk about 1,300 meters deep. So we talk about if we have a suspension bridge crossing, this should cross this. And just to give a perspective, we talk about the troll platform is 460 meters. So this is a challenge that requires to cross in this fjord. And just another comparison, we can see that, for example, Northern Bridge, but 1,500 meters, or compare with Akashi-Kayo Bridge, is how the project looks like. And also, our project needs to have a clearance to ships, special cruise ships crossing this fjord, because this is the main interest to the most famous fjord in Norway, Geiranger. So just to have a perspective, if I put the Akairo Bridge in the same project, if we have a perspective how this could be. So you can see there is could be very big suspension bridge, maybe the biggest in the world. So if the suspension bridge process could be this, we talk about crossing 3,700 meters with two main lines connecting by small deck elements to connect the roads. This is a challenge, not just the bridge, but for example, the towers to hold the cables should be almost 500 meters higher. So this is still is one option to this bridge. The government's not already decide which option we're gonna be. The other option could be the floating bridge system, and you have the floating system to support the bridge. That could be another option. But as I say, this is maybe the most challenging crossing in the world. It's still not, the government still not decide what they're going for. This is just a simulation of how could it be the deck of the bridge. In fact, should be two bridges connect in the middle by some beam system. Here is another option, is submerged tunnel. Submerged tunnels would be a tunnel that is floating, anchored by floating system and anchored in the middle of the bedrock. That could be an option also. So this the point of view of the engineer would be the most challenging and interesting bridge ever made. There is a lot, let's say, people that was eager to see this being made, and was a lot of discussion about this process. So there was supposed to be two the sections of prefabricated concrete sections, tunnels, connect each one, and for begin have these two lines traffic, and each element could be anchored by floating system and would give passes to ships. Of course, this is a project. It's not decided yet. So this is just overview what was the design process. Was a lot, as I said, was a lot of discussion in the government. The problem was the authorities was not convinced to use this process because was never have been made before, and when come the costs, what is new is very difficult to quantify what be the final cost of this process. Another section of how will be these tunnels and how they are anchored in the seabed and how they are stay together, and of course the safe system and safe passage system. And of course there was another option was cable stayed bridge, but using floating columns that was fixed on the seabed. Nowadays, this was considered the more feasible option because there is a lot of experience from offshore structures how to be floating elements. So that was considered the most maybe appropriate solution for this bridge. But as I say, there is no green light from the government yet. there is no, they have not decided what the project they will try for. Another example of the floating bridge sections that could be used. There are the other fjord that was kind of challenging, Bjornfjord. Could be very challenging also, but this was decided will be the winner project will be this combination suspension bridge, stay bridge with floating bridge. That was decided by the government, and the fact they want to use this Bjornfjorden crossing as a test to see if they can go to the same solution to Sognefjorden. The other options that was considered to the same fjord was floating bridge elements, and of course the winner was the floating sections elements. Also was considering submerged tunnel, and there was a lot of engineers and that was eager to use this solution just to have as a test for Sognefjorden, but the winner was floating system columns. Well, of course, we have to consider that crossing bridges sometimes can give you some problems, especially when you are in the coast. And this is a good example that something that could happen when you are crossing a bridge during a storm. You have to stop the bridge because sometimes the winds can be very strong, so they have to stop. And that was an example when they tried to cross during the windstorm. So that's how they decide to do that. They decide to use another solution, tunnels. And right now the two big projects that was on developing was the Rogfast and Ryfast tunnels. The Rogfast tunnel was supposed to be finished in 22, but because of the costs, this process is delayed to 2029. But the Ryfast was planning to finish in 2019 and was finished, and it was open in January of 2020. Of course, these projects are just a step forward to have more tunnels connect in the area of Stavanger. So those projects should be a part of the series of new tunnels that has to be built on this area. Well, we talk about the Ryfast tunnel or tunnelen in Norwegian or Ryfast tunnel. Well, this tunnel have the winner the title of the world longest subsea road tunnel because it's almost 20 kilometers, 15 kilometers long, and have the deepest of minus 290 meters below the sea level. Have two lines, tube. The approximate traffic was 8,000 cars a day in 2035, but nowadays this almost 4,000 cars a day. So this tunnel was opened recently, and this is just an overview of the main entries on one side is the main entries on the Stavanger side. So this just to see this process. The tunnel was construction with the explosion process when they drill the rock, and first they make sure that there is no water in the process. If it was water, there was seal water, and then it was drilled to place the explosives and explode, and then go on with excavation. And our section was, of course, anchor in the rock, and the concrete sections that were use as tunnel revestment was anchor in the rock. So this is just the process that they have used. And this is another overview of the process. So you can see here the anchors that was put in place in the rock. And here is another view of the tunnel after finish. And this is the most interesting part, to celebrate the deepest tunnel in the world. They make this section, and this is my personal experience. That is very interesting when you drive this tunnel and come to this section that is complete blue. It's a very pleasant experience to drive. So you can see that's very spectacular when you know that you are in the deepest section of the road. That's a very good experience. And I have to admit, this is a very safe, you feel very safe on this tunnel. Well, but not this really fast, still have the title of the longest, but if the Rogfast tunnel crossing the Boknafjorden believe finish, then we lost the title for this tunnel, because Ryfast was supposed to be the world record subsea tunnel, which is expected to be 27 kilometers long and 392 meters deep below sea level. This tunnel started the process this year. Was supposed to start 2 years ago, but as I say, because of the costs and some designs aspect of the project, they have some delays. This is the sections that will be 4 lines. So that means it will be 2 tunnels at the same time, separate from the middle. So there are 2 independent tunnels. The section will be excavated on the bedrock. That was the main reason of the delay of the project, because they have to have a complete mapping of the rock. And this section will be not different from the other tunnels built in Norway. It will be almost the same characteristics of the Ryfast tunnel. The only difference is the length is, as I say, 27 kilometers and almost 300, we can say almost 400 meters below seabed. But besides that, we have to consider another thing. We have this island, ship's oil. So the government has decided that this island should be connected also to tunnel. So that means that besides have to be very deep, you're gonna have the biggest, we can say, roundabout in the world to connect this island with the tunnel. So this is the process they have planned, and they start already now. So you're gonna have a lot roundabout inside the tunnel that allows you to connect with this island. This is a section overview how they planning to be. So you can see this is planned to have a lot of ventilation shafts, and the tunnel go very deep in the rock. Images escape out each 500 meters and in the intersection with the sheets oil. So this is how you'll be if you drive this tunnel. So this is expected to be already start the process, and I hope soon this be finished. I can have the experience to drive on this tunnel and share with you again. So this is just an overview how the project will be handled. So that was my intention to give a good overview what the Norway is doing in the infrastructure terms, and all information was based on the Statsvegvesen website where this project is held, and more information can find on the website. So thank you for listening, and I hope you had enjoyed this experience as I have enjoyed presented for you. Well, see you. Bye bye.